Hello and welcome to another video on frequency tables, and in this video we're going to be focusing on grouped frequency tables, and we're going to calculate the mean, median and mode of a grouped frequency table. So this first example that I'm going to go through, it says the frequency table shows the weights of 43 cats. So you've got the weights in this column, and you can see it's a grouped frequency table because you've got these groups instead of individual values. And you've got the number of cats in this category or in this column here. So this first example, this first cat here, we know that that weighs between 2.5 and 3 kilograms. But these inequality symbols tell us a bit more. So it tells us that it's greater than or equal to 2.5 kilograms. So it could equal 2.5, that would fit into this category. But it's strictly less than 3 kilograms. So if this cat was 3 kilograms exactly, it wouldn't fit in this category, it would go in the one below because this is less than 3 kilograms. So let's calculate an estimate of the mean weight of the cats. Now, the reason why it says estimate here is because we cannot calculate an exact value of the mean because of these groups. So like I said before, this cat here, we don't know what the weight of this cat is. It could be 2.5 kilograms, it could be 2.6, it could be 2.9. We don't know the exact weight of the cat, so we can't calculate the mean because we don't know what each cat weighs. So that is why we only calculate an estimate of the mean. And that's the case for any grouped frequency tables. It's always going to be an estimate. So we know it weighs between 2.5 and 3 kilograms. So the best estimate we can use to calculate what weight this cat is we pick the midpoint. So whatever interval we've got, we always take the midpoint of that interval. So you can see here, I've just made another column. So if I write down the midpoints of each of our intervals, the first one is going to be 2.75 kilograms, and then 3.25, 3.75, 4.25, and finally, just need to be really careful with this last one because you might just be tempted to say 4.75, but the interval's slightly different. So this one goes from 4.5 to 5.5, so the midpoint of this category is 5 kilograms. So just make sure you're looking at the intervals and picking the midpoint. So now what we're going to do is we're going to just assume that this cat weighs 2.5 kilograms. We're going to assume that all of these 8 cats weigh 3.25 kilograms. We're going to assume that all 16 of these cats weigh 3.75 kilograms, and so on and so forth. So what is the total weight of the cats in this category? Well, we've only got one cat and it weighs 2.75 kilograms. So the total weight is going to be 2.75 kilograms. The total weight of all the cats in this category, well, it's going to be 8 multiplied by 3.25 because there's 8 cats. They each weigh 3.25, or we're assuming they each weigh that. So we're just going to multiply these together. So let me just get the calculator out for this. 8 times 3.25, and that gives me 26 kilograms. So to work out the total weight of all 16 of these cats, we're just going to multiply again. So 16 times 3.75. That gives us 60 kilograms. So notice I'm just multiplying the frequency by the midpoint. So the next one is 14 times 4.25, which is 59.5. 59.5. And finally, 4 times 5, all that will give me 20. So now we've got the total weight for each category. To work out the weight of all of the cats in total, well, we can just add up all of these values. And when we do that, we get 168.25 kilograms. So this is the total weight of all of the cats. So now to work out the mean, we just need to divide this value by how many cats we've got. We could add up all of these frequencies, but I can see in the question it says there are 43. So there are 43 cats in total. So to work out an estimate of the mean, we do 168.25 and then divide that by 43. So let me put that into the calculator. And I get 3.9, I'm going to round to 2 decimal places, 3.91. So 3.91 kilograms. So that would be my answer. Now you should always do a dummy check with your answer just to make sure that it does make sense. So the mean should be between the lowest and highest values. Well, the lowest value we used was 2.75 kilograms and the highest value we used was 5 kilograms, and you can see that 3.91 does sit somewhere in the middle, so you should be quite confident if you did get that answer. Now moving on to question 2, it says calculate the modal weight class of the cats. So all this means is which weight class contains the mode. So we look along the frequencies to see which one is the most common, and we can see that there were 16 cats that weighed between 3.5 and 4 kilograms. So this is our mode. This is our modal weight class. So it would be 3.5 is less than or equal to X, which is less than 4.0. So make sure you write the whole thing down with the correct inequality symbols. And finally, question 3, calculate the class in which the median weight of cat lies. So to work out the median, we're looking for the middle number or the middle weight of the cat. So we've got 43 cats in total. So hopefully you remember that to calculate the position of the median, what we do is we add 1 to the total frequency and then we divide by 2. So we're going to do 43 plus 1 divided by 2. So 43 plus 1 is 44. Divide that by 2, we get 22. So we're looking for the 22nd cat, and that will give us the median. So we can see that the first category, well, we've just got 1 cat here. Now, if we add on the next 8 cats, how many have we looked at in total? Well, we've looked at 9 in total. So these are the first 9 cats. And then these next 16 cats, that's going to take the total to 25. And because we're looking at the 22nd cat, it will be in this category here. So the median class is exactly the same as the modal class. It's going to be 3.5, which is less than or equal to X, which is less than 4.0. In this extra category that I did, this is called the cumulative frequency. So if we were to carry on with this column, we don't need to, but let's just do it anyway. The next 14, that would take us to 39, and then the next 4, that would take us to 43, which is all of the cats in total. So these are the 3 answers that we've got. So what I'm going to do now is I'm going to give you one to have a go at. Here we go. A travel website sells weekend mini breaks. The cost of the mini breaks are summarised in the table. So pause the video and see if you can answer these 3 questions on the mode, the median, and an estimate for the mean. Okay, so the first question, calculate or state the modal class. So the modal class, that's just the class that appears the most often. So we look at our frequency column and we can see that 9 is the highest number, and that corresponds to this class here. So this will be our answer. Okay, part B, work out the class in which the median lies. So the median is just the middle number. So first of all, we need to work out how many mini breaks there were. So to do that, we just need to add up these numbers. So 4 plus 7, that's 11, plus 8 is 19, plus 5 is 24, plus 9 is 33. So there were 33 mini breaks in total. So the median, or the position of the median, we add 1 and then divide by 2. So it's going to be 33 plus 1 divided by 2. So that's 34 divided by 2, which is 17. So we're looking at the 17th mini break. So it's definitely not going to be in the first category. There's only 4 there. We look at the next category. We've got another 7. So this is going to take us up to 11. So just to show you what I'm doing here is I'm calculating the cumulative frequency. So I'm just adding these numbers as we go along. So these ones here will be the first 11, but we're looking for the 17th. So if we go into the next category, we add on these, that will take us to 19. And because we're only looking for the 17th, it will be in this category here. It will be one of these ones. So our answer, the class in which the median lies, well, it's this class here. And finally, part C, work out an estimate for the mean. So again, we can't calculate an exact mean because we don't know the individual price of each mini break. So we're going to have to calculate an estimate. And again, the best way to do that is to use the midpoint of each category. So first of all, let's calculate the midpoint. So the first row, this is going to be £180. And then this one is £220. This one is £260. This one is £300. And finally, £340. So what we're saying is that these 4 holidays cost £180 each. So the total cost of all of these 4 holidays, we are just going to multiply the frequency by the midpoint. So 4 times 180, that gives us £720. The next one, well, that's going to be 7 multiplied by 220, which gives me £1,540. And then we're going to do 8 times 260. So that's £2,080. And then 5 times 300, well, that's 1,500. And finally, 9 times 340 is £3,060. Well, that's not very clear. Let me make it £3,060. So now we know the cost, the total cost for each category. To work out the cost in total for all of the mini brakes, we just need to add all of these together. And that gives me £8,900 in total. So to calculate an estimate for the mean, we take the total cost, which is going to be £8,900, and we divide that by the number of mini brakes, which we know is 33. So let me put that into the calculator, and I get £269.70. So I'll just round to the nearest pound, so that comes to £270. £270. And again, let's dummy check our answer. So our answer should be between the minimum price of a mini brake and the maximum price of a mini brake, which we said was, the minimum we said was 180, the maximum was 340, and luckily for us, our answer fits nicely in between these two values. Now, just before I finish this video, I'm going to give you one last question, which is all about identifying true and false statements from a grouped frequency table. Now, what we've got in this grouped frequency table are the heights of London's tallest structures, and we just need to shade which statements are true. So the first one, the class widths are all equal. So here are the class widths. So we can see the intervals. The first one goes from 100 to 120. So that's a class width of 20 meters. The next one's also 20 meters. This one's 20 meters, but this one here is 40 meters. So we don't need to go any further. We can see that they are different widths. So this one is definitely false. The next one, the modal value is 6. Now, you might be tempted to say true because there are 2 6s, but that's not how we calculate the mode. To calculate the mode, we do look at the frequency column, but what we're looking for is the highest value. So the highest value here is 23. That's the most common. So we look at this category here. So 100, which is less than h, which is less than or equal to 120, that is the modal interval. Okay, there was the most number of London structures at that height. So this one is also false. Okay, the next one, there are 63 values in the data set. Well, to calculate the total number of values, we just need to add up all of the frequencies. So 23 plus 16, that's 39. Plus 11 is 50. 56, 62, 63. So the total value is 63. So I can shade this one as being true. So that is true. Okay, the next one, it could be true that 7 structures are taller than 225 meters. Now this one's a bit trickier because there isn't a category for 225 or greater. So if we look at this structure here, this is definitely greater than 225 because it's bigger than 250. So that one will definitely be included. Now these 6 here, we don't know the exact height, but it is possible that they are all greater than 225. Because they are somewhere between 200 and 250. So they could all be between 225 and 250. So if we take these 6 plus this one, that does give us 7. So this one is also true. So the key word in this one is could be true. So obviously we don't know what these are, but it is possible that they are all greater than 225 meters. Okay, the next one. 39 structures are less than or equal to 140 meters tall. So this is 140, so we can't include anything below this line. So it's going to be these 23 plus these 16, and that does take us to 39. So this one is also true. We've got 3 trues in a row. Doesn't mean the next one's not true, but let's have a look. It is possible to work out the exact mean from the table. Well, no, we mentioned this before. It is not possible. We cannot calculate the exact mean because we don't know the heights. All we know are the height intervals. So this one is false. The next one, at least 10 of the structures must be less than 110 meters tall. Now, again, we don't have a category for less than 110 meters. All we know is it goes from 100 to 120. So there's 23 structures that are between these heights, but we know nothing more. So all 23 of them could be between 110 and 120. There could be 0 that are between 100 and 110. So this one is also false because it says at least 10 of the structures. We don't know. There could be 0 structures that are less than 110. So that is also false. Now the last statement says one of the structures must be at least 3 times as tall as some of the others. So again, we don't know what the individual heights of the buildings are, but we do know that the smallest building will be between 100 and 120 metres, and the biggest building is going to be between 250 and 350 metres. So they're saying that the biggest one is at least 3 times as big as the smallest one. So let's try and disprove this statement by finding the minimum possible difference between the biggest and the smallest structures. And to do that, well, we're going to be looking at the biggest possible height for the smallest building and the smallest possible height of the biggest building. So all 23 of these could be as big as 120 metres. That's perfectly fine. If all 23 of these are 120 metres, they would fit into this category. And this building here, this could be as small as 251 metres. So it can't be 250 because that would fit into this category, but it could be 251. That's perfectly fine. Now, hopefully you can see that this here is definitely not 3 times as big as this. If we multiply 120 by 3, well, that will give us 360 metres. So no, we cannot say for sure that one of the structures must be at least 3 times as tall as some of the others. So this one here, it could be, you know, if this is 350, if we make this the maximum and we make one of these sort of 101, then yes, it would be 3 times as big, but we can't say for sure. So this last one would also be false. Now we've come to the end of this video, but hopefully that was useful to you, and hopefully I'll see you in the next one. Take care.